Thank you, Marco, for inviting me here, and thank you to the Lotico community and to all the audience now for being present now. It's a nice occasion to show where VocBench comes from and where it's going to land in the next years. Okay, so since I think that I can share the slides later, no? This is I like to share with all of you the full presentation that contains a lot of insights on all the features that VocBench has. It's not super detailed, but since there are a lot of features in the platform, it's like more than 120 slides. So obviously, I will not use this for this presentation, but I mean, if you all like, I will share the full presentation with all of you. So just a few words where I'm working. Marco already introduced me, so I will be very short on this. I work at the University of Rome Tor Vergata. It's the second university of Rome. It's built like a campus, so it's distributed over a large area. It's in the southeast part of Rome. It has all the most important faculties. It's born as a sort of polytechnic. The faculty of engineer is quite large and widely frequented. This is the VocBench team. It's actually it's just a short screenshot, and I should make it bigger now to include, for example, just now Johannes introduced it before. We have now Johannes in charge of the marketing of VocBench for our spin-off company of the University of Rome Tor Vergata, Lorster. And this is the core development team. Actually, the team is larger now. There are around 7 people, but these are the ones that bring ahead, let's say, the core of the system. It's me, Andrea Turbati, Manuel Fiorelli, and Tiziano Lorenzetti. I'm working still. I code still sometimes, but yeah, now I have to lead the project and also lay the line for design, etc. But Manuel Fiorelli is curating most of the architectural leaps of the platform. Andrea Turbati is working on the service aspects, and Tiziano Lorenzetti is working more on the surface. That means the web interface, but not only, also is working on the service side. And basically, all of us are quite exchangeable in sometimes swaps roles, but this is more or less what we are doing for the platform. The one on the right is not a list of the users of VocBench. Luckily, the list is much bigger, but this is just an extract of those users that were present at the first stakeholder meetings that were organized by Johannes. Because at the time it was VocBench, Johannes Kaiser, that you have heard before, is not only the father of AgroVoc, but he's also the father of VocBench. VocBench was born within FAO, as you will see in the next slide, and within a European project. So later on, there was interest from more organizations, more groups within FAO, and we got another funding from the ISA Square program of the European Union for a completely revamped version of VocBench. So there was the organization of this stakeholder meeting, and in a sense we can say the VocBench is really something that obviously there is a top-down design, but there is also I mean the lot of requirements that came down from the users. Europe is the provider of the European Union, was a contract for within the ISA Square framework, and is subcontracting us for the development of the platform. So, okay, I already anticipated something. VocBench was born within Neon. So this is the FTL stands for faster than light. VocBench has been initially developed within the Neon project. It was a project from the 6th framework of the European Union. And it was not even called VocBench. It was called AgroVoc Concept Server Workbench, and a lot of other names. At a certain time, we decided that I was working for FIU at the time as a consultant, and there has been a decision, since there was much interest about the platform, to make it something that was not tailored around AgroVoc, but to make it a more general purpose system. So that was the start of VocBench. And like I said before, at a certain time, we had to just have this more general purpose platform compliant, natively compliant with the semantic web standards. So at my university, I was already developing another system that was called Semantic Turkey. It was called, developed as originally as a semantic annotation platform. The web interface was actually a plugin for Firefox. And but later on, you know, the more you hit, the more you get hungry, it became a fully fledged RDF management platform. So we literally stripped the core of the VocBench platform, leaving all the user interface and all the user experience. So to avoid that the user that were already acquainted with VocBench would find themselves, you know, in a foreign territory. And we literally made this Frankenstein by putting the front end of VocBench and other aspects of it together with the core Semantic Turkey platform. So this Frankenstein lasted as much as we could, in the sense that it was developed really as a kind of 6 months projects in which we put them together, and we realized this general purpose platform that we were aiming for. When I say general purpose, I'm talking still about Thesauri. It was no more tailored around AgroVoc, but it was a platform for still tailored for Thesauri, for SKOS and SKOS Excel. So later on, when we got this funding, I said, okay, I have a clear idea where I want to go, but we need to go out to go beyond this Frankenstein system that we made with VocBench. We needed to do it from scratch, reusing what we did well, and just making it bigger and better. So this is VocBench 3, where we are now. It's funded, like I said before, by the ISA² program, and it sees the management of the whole project by the European Commission, in particular the Publications Office of the European Commission. So let's go now to VocBench 3. I will go very quickly on the requirements because I want to show you more of the platform and less of the introduction, which maybe some of you have already seen in other presentations around. So just quickly, multilingualism, this is fundamental because it came from the original requirements of VocBench. AgroVoc, that was the, you know, the data set, the Thesaurus that fired the development of VocBench. Its strong point is surely multilinguality. It is maintained worldwide by a community of several organizations that rotate around FIO and contribute to the system, to the data set. It's now available in more than 30 languages. So multilingualism obviously was a main point for VocBench. Controlled collaboration, because again, it is meant for developing Thesauri and other resources together. Data interoperability and consistency, software interoperability and extensibility. We wanted a system that was not too, how to say, too static. We wanted something that could be extended, something that could easily integrate with other systems. We wanted data scalability and software scalability. That is the possibility to load even very large data sets and the possibility to scale out the code without having to repatch everything because something doesn't adapt. Possibility for different figures. I'm going just not really linearly with this. I'm just skipping some of them. The possibility to have different figures working on the same platform. We want, RDF experts to check every single triple in the data set and be able to do that in the most convenient way through the user interface. But we want also more, let's say, naive users, or let's say users that are not too technical, but maybe are domain experts too, or maybe they have some skills like they are lexicographers. No, we want them to work without caring too much about the details of RDF and more caring about the content. Another important point is that we didn't want to make a Thesaurus editor. Now with VocBench 3, we wanted to do something that has no limitations. So VocBench 3 is an OWL ontology editor, a SKOS Thesaurus editor, and an RDF dataset general editor. It's a data editor. There are also other supports for other standards like SKOS Excel, and also we added Ontolex-lexicons to the possibility. Ontolex is a recent standard for the management of lexical information. Maintainability, I already said something before about that. Full editing capability. So everything, like I said before, must be observable through the interface. There must not be, let's say, first-class citizens that can be reached by the interface and others that remain hidden because they are not covered by that kind of modeling. When I say that there is support for OWL, for SKOS, for Ontolex, it means that there are dedicated interfaces that allow to model things in an easier way than it would be by actually editing things triple by triple. If you are familiar with the OWL axioms or with the long series of indirections that are present in Ontolex, or if you just know verified labels like SKOS Excel labels in SKOS, you know what I'm talking about. But this is the support for OWL, SKOS, Ontolex, etc., is a set of facilities for doing things easier. But in any case, VocBench has no first-class citizens. Any resource is editable and is visible in VocBench. Provenance, we have support for provenance, and we adopt the vocabulary provo for that, and we extend it for depending on the functionality that is provided with additional information. Support for versioning. It's possible to dump once in a while a system and do a sort of time machine across the various systems. We make a large use of metadata. We want to foster actually the use of metadata. The semantic web, the linked open data cloud now is full of data sets. I mean, it's finally starting, but each thing is just not easily reachable, at least not always. I mean, there is only a fraction of the data sets that are properly advertised on the web. An important thing is being able to follow your nose. If you know something about a dataset, because you even just get a URI about a resource that is present in a dataset, you should be able to look up it on the web to get all the information and being able to retrieve all the other information from that dataset. So VocBench exploits metadata, but also allows the user to produce metadata ready for publication. Customizable UI, for example, custom forms, we'll see an example later. And everything is RDF. We don't use databases or other technologies. Everything the data is stored as RDF, but even metadata of the application itself, the users themselves, etc., are stored in some cases directly as RDF. In some cases, they're stored in some configuration files, which are in any case leveraged at the start of the application and represented as RDF. Just a few words about the technological stack. We have a lightweight presentation layer that is based on the Angular technology, a business logic that is substantially based on some semantic turkey. Semantic turkey was the platform I mentioned before that was Frankensteined with VocBench, with the previous version of VocBench. We could say now that the third incarnation of VocBench that I'm presenting now is it's actually semantic turkey on steroids with a web application. So all of the business logic, everything in the server is managed by this platform. It exploits notable frameworks like Spring and AspectJ for aspect programming, and OSGI for modular management of services. We have then specific triple store optimizations that lay on top of the middleware that is the popular RDF for J. And then we have the connection to a specific triple store. This is just a rough view of the architecture. Just the main building blocks are present here. One thing that is worth mentioning is that every element can be extended somehow. The data layer, in the sense that we can build then a specific connector to a triple store. The middle layer, in the sense that we can have extensions of services and we can have implementation of several extensions points in the platform. And finally, the user interface. Unfortunately, we cannot have at the web level extensions such as in other tools like Protégé, but it's the same in Protégé as well. If you take the collaborative version of Protégé, Web Protégé, they don't have the same kind of extensibility at the user interface level that they have with the desktop systems. Unfortunately, this is a limitation of these new frameworks, and but something is boiling up, and I hope that we will have better success in the future. For now, what I can tell is that we have a dynamic user interface that reacts to the extension points that are deployed at the service level. And this is able to build dedicated, for example, configurations by only getting informed, being driven by the data on the server. VocBench availability. It's available as a standalone web application. It's very easy to install. You just need to download Java 8 for your platform, and then download the zip file, which contains only Java technologies and web technologies. So everything is multi-platform, platform independent, sorry. And this way you just need to have Java installed and click on the caraf bash that you find within the distribution, and it starts. And that's all. You can use it even as a desktop application because there is no configuration to be done in this sense. And then if you want to make things more complicated, put firewalls and have reverse proxies, etc., then obviously you might tinker with the configuration to meet your needs. There is also Docker distribution. I suggest the Docker distribution for those who are familiar with Docker. By no means Docker is easier than the standalone web application. The standalone web application is something very easy. Like I said, only Java, and then download the zip file of the system and run it. So a few words about the features before I start to play with the platform. So this is a view of the system. Obviously, this is actually I collated together more screenshots because normally you scroll to the information of a single resource. This is the UI, as you may see, the main data view of the platform. You have in this case, we are watching a thesaurus. You have on the left the tree of the thesaurus, and on the right all the information. Notice that this panel here is not meant for concepts. This panel is very general. We call it the resource view. The resource view is made of components. And each component is driven by what we call a consumer. That is, normally there are some queries that are fired on the dataset for exploding the description of one resource. And then there are consumers which get this information and reorganize it depending on the resource that is being shown. There are some, let's say, elective properties that you want to see for certain kind of resources. In this case, for instance, we have a concept, and you might see as a first thing the type telling you that it's concept, and then since it's a concept, you see the top concepts, the concept schemes it belongs to, or better, sorry, the schemes for which it is a top concept, the schemes to which it belongs, then you see the lexicalizations, and so on. So there is multilingual editing. I can say it's a fundamental part. The rendering is multilingual. You might see the same concept rendered according to different languages, so you might choose them. And then there are language preferences. For example, you can choose those used for the renderer. You might choose to filter those that are shown in the description of a concept. You might decide if you want to see flags or you prefer to go for language codes. And then also the UI is multilingual since version 9 or 8, I don't recall. No, it's version 9, the one that we released just now. It is possible here to select another language, and then the user interface will change to that language. This is another important feature. We will see it later, so we'll not spend much time. This is a language for describing forms that you can use to prompt your data. Role-based access control. It's a collaborative platform, so it's very important to be able to assign roles to user and to confine the kind of actions that they can do on the platform. You don't want a new byte to ruin your new thesaurus. So maybe you can assign different roles to different users depending on their competences. One thing that is worth mentioning is that I called it role-based access control because this acronym RBAC is very famous in collaborative systems. But actually what we have is something that is definitely more fine-grained. What we have is capability-based access control. Each action is defined in terms of the capabilities that are necessary to perform it. And then what is a role? For us, a role is just the union of a series of capabilities. We have a system, it's written in Prolog, that reasons when this is the capabilities that are necessary for performing a certain action and compares it with the capabilities declared by the user, which might be expressed in a different way. But if the capabilities declared by the users entail the range of capabilities that is necessary for performing the action, then the action might be performed. And we have a Prolog implementation that is both server-side and client-side. The client-side is made only for checking at the UI level what should be presented to the user, but obviously has no definite control over what can be done. This is because you can easily hack any client, by working on the inspection of the page on the browser. But ultimately, is the server the last gate before the action is performed. And let's see, so this is a screenshot of the editor. It's a visual editor, but then there are some details that you can add in by tapping on it. Extensions, there are basically 3 levels of extensions: sale extensions, service extensions, and extension point. The sale mechanism is a mechanism provided by the middleware that has been chosen by us for developing VocBench, that is RDF4J, and it allows to deploy certain extensions directly in the triple store. This is for a matter of performance and also visibility of information. For example, we have these 2 kinds of sales. One is the change tracking sale, and another one is the trivial inference sale. Let's think about the change tracking sale. It is in charge of history and validation. History is simply history of the actions that have been performed, and validation is a list of actions that, if validation is enabled, need to be confirmed by dedicated users who are called validators. In order to perform these at the best level, the idea is to be on the side of the triple store and not on the application, because you need to know exactly what requests have been done and how they have been carried on within the triple store. For instance, if I perform an action which asks to write the following 3 triples, A, B, and C, and suppose that the triple A is already written in the triple store, the action passes, maybe if there are no other constants that fail it, but the triple A is de facto not written because the triple store already finds it written. So the triple store will record the fact that only triples B and C have been really written at that time. So this is just one example, one tiny example of the fact that it is a good thing to have these kind of extensions that can communicate with the platform and can receive commands from the platform, but at the same time need to be close to the triple store, in particular deployed within it. This is how the validation mechanism appears to the user. When you create a new, suppose here I don't like this label, I want to remove it, and since validation is enabled, the label is not directly removed, but it's simply slashed and colored in red. While when I write a new one, contrattisti, it's written in green italic, and it's considered to be suggested and needs to be validated. So the tracking system is based on another repository that is called the support repository, and there all the triples are written reified. This is because we need to add to them more information, such as the moment in which the request has been done, the moment in which it has been eventually approved if validation is enabled, who performed the action, and many other information that characterize the metadata of the triple. There is also some graphs in the main repository which are used for depicting these things. I mean, this information here, the contrattisti in italic green and the one in red stripe through, come from non-reified triples, which are written in a dedicated graph and thus can be queried together with the main information. But the full information with all the metadata is written in the support repository, and obviously they're always synchronized. This is how the history and validation appears. Actions are immediately derived from the code implementing the available services. This is about what I said about software scalability. We don't need to do a lot of work when we add a new service because everything is already perfectly intertwined with all the architecture of the system. Whenever we add a new service, we decorate the service in the code with appropriate annotations so that when the action of the service is performed, it will be logged properly in the validation and history system. This way you can see the number of parameters that are being asked. And if you have, this is a small screen, it was like 800 per 600, but this, you can see more parameters. The bigger the screen, the longer list of parameters you can see. And then there is you can see here, there are only 2, first and then others. If you get bigger screen, you can get second, third, and so on. Then you see the name of the user with its URI, the date, sorry, the URI, this is the email that has been used for registration, but there is an internal URI for the user. The date in which the action has been performed. And if you click here, you can see the details of the action. For example, here the commit details tell that the following 4 triples have been added. There is also blacklist. If you suppose you want to add a new concept and somebody rejects it because it says that it doesn't make sense to exist in your thesaurus or I don't know what, later on, somebody does the same thing and adds the same concept or adds the same label, I don't know. And then they get an alert with the information that has been provided at the time of the first rejection, telling why that term has been rejected. So you might decide if they are right, or maybe something has changed in the thesaurus, in the purpose, in the objective, in the scope, and thus maybe you want to, maybe it's time to try it again. So it's just an alert system, but it's very useful because then you avoid to repeat the same errors again and again. Okay, there is a trivial inference system. By trivial inference, I mean not really what a full reasoner would do, but simply being able to assert directly, so they are not staying in a dedicated space of reasoned information, but to explicitly assert triples that you would like to see in the published resource. This means the materialization of trivial things like, for example, inverse properties. If Tom loves Mary, no, sorry, love is not necessarily a symmetric property, but oh, okay, you might want to say that Mary is loved by Tom by taking the inverse of love, no? So such trivial facts might be inferred by a reasoner if you expose your data with a reasoner, but you might want to have it being part of the main, let's say, of the core part of the dataset. This is also exploited by, this is also realized by exploiting the sale mechanism. Service extensions, okay, I will not go into the details of that, but just for developers who might be interested, we use we make a massive users of annotations that we also created specifically for the framework. So you might see that all this business part of the code that is just doing boring things such as verifying that a certain resource is existing and then checking if it's existing in a given graph and blah, 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 can be simply obtained by adding all these annotations that we created for the code. So let's say the build of the development of a service is very much declarative because you have this part, which still does nothing in terms of actually performing the action, but performs a lot of actions that are necessary to do the main one, like verifying the authorization, checking that it is a read action. If there is a read action, nobody can write anything. This is also done by means of aspect programming and the fact that, for example, when you get a repository, this repository is actually a copy that is not able to write. So a repository connection, I mean. So actually this avoids that somebody might make malicious code, like telling that a certain action is a read and actually performs a write. And so on. The service operation here declares that this is a new service and so will be published automatically when it's plugged into the system. Extension points, there is a long list of extension points. Here we have collaboration backend. Currently, there are 2 implementations for Jira and FreeCamp that are 2 popular collaboration environments. There is, for each of them, there is always an implementation that specifies how the elements that need to be vetted or discussed by the community users are represented in the specific collaboration environment. For example, in Jira, we use the strings attached to fields. In FreeCam, we use the fields and so on. So basically, as it is for all extension points, there are some functionalities which are already well defined within the system, and then there are implementations that allow to connect to different kind of technologies. The dataset metadata exporter allows to create and export metadata for a given dataset. This is mostly like form filling, but for some metadata vocabularies such as void and lime, which have a lot of statistical information, they also compute this statistical information and automatically export them in the saved file. Input output, basically there are both for input and for output the possibility to retrieve or deploy information to and from different sources, like from a SFTP server, an HTTP endpoint, a triple store, or Onto portal. We added recently, I heard somebody mentioning before one of the Onto portals, and so there is an extension for supporting export of data to Onto portal, and also the possibility to reformat the content, both for lifting content that is not in RDF to RDF, and for doing the opposite. That is, you have some content in, you have your dataset and you want to export in some other format, and then you can do that. Currently, there is an exporter for the ZTES XML standard for Thesauri, and also custom Excel export for Thesauri also. Rendering engines, these are very important for offering different possibilities for rendering the resources. So you don't have to see necessarily the URI or the QName, but you can see it represented through different information that goes together with it. Basically, the standard rendering engine that is already coming with VocBench is also configurable. So the extension point is really if you want to do something completely different. There is a URI generation engine bundled with VocBench, but it's possible to change it with one another. For example, if you want to create URI in a very particular way. Again, the URI generator that is bundled with VocBench is also configurable, but if you want to do it in a very different way, I don't know how, then you might build your own URI generator and plug it to VocBench. There are dataset catalog connector. Okay, we will see it later. So I think that we might stop here for what concerns the presentation of VocBench. I prefer to stay a little on the slides because there are a lot of things that if I stop doing them action by action on VocBench, it would be very long to do it, and then I would only show you just a few of the functionalities available. So I prefer to give you this overview, and later on we will discuss some of the specific functionalities. So let's see. By first, this is the list of projects in VocBench. I'm accessing to different installations. This is one that are local. The list of projects can be configured with metadata, and you can also specify the kind of folding that you want. For example, I might decide to use the list, and then in that case, I will list a complete list of projects that is sorted alphabetically, or the facet-based view. In that case, I might choose the facet that I'm going to choose for creating the folders. Let's see how a project is structured by trying to create one. We don't need to create it in the end, but I just want to give you a look at what can be put in the creation of project. But trivially, the project name. Then there is an optional data preloading. This is very convenient for what we will see before, so I'll come back to this later. You can define here the base URI of your ontology or dataset. I don't have to go into explaining what is a base URI. I assume that all of you have familiarity with these things. And a few words instead about this. The model and the lexicalization model. This is not something that is, let's say, standardized in web technologies, but in semantic web technologies. But somehow we know that we have different models for representing information. We have, I'm talking about core models. So I'm not talking about domain models. I'm talking about what do you want to do, an ontology, a thesaurus, a lexicon. Then you need different core vocabularies of a combination of them. So we have here various possibilities, RDFS or OWL for ontologies, SKOS for thesauri, Ontolex for thesauri, and for creating interfaces between lexicons and ontologies, and IDOAL. IDOAL is a standard for representing reified alignments. You might see here that SKOS XL is not here, for instance. It's because it's here. Why? The RDFS here, SKOS, SKOS XL, Ontolex are just referring to the portion of those vocabularies that are related to lexicalizing content. RDFS offers a very tiny possibility, just the RDFS label, which is, however, more than enough. If you are, for example, representing an ontology and just want to provide some natural language content for making the names more understandable in different languages. SKOS has a terminological approach and offers as a basis 3 kind of labels: preferred label, alternative label, and hidden label. SKOS XL offers a reified version of these labels, in that each label is a URI itself, it's a result itself, it belongs to a class, it's a member of the class, it's member of the class SKOS XL label, and has a specific property that is the literal form, telling in the end what is the literal content of the label. And finally, Ontolex. In Ontolex, we have a much more detailed description of the lexical asset of a dataset, because you can describe lexical entries. Each lexical entry might be described by different forms, because for a verb, you might have different tenses. For example, you might have conjugations for nouns and so on. In this case, we differentiate. Obviously, there are, let's say, elective pairs. If you select SKOS XL here, standing to the manual, nobody forbids you from using it for our ontologies. But usually, if you're using a lexicalization model, SKOS XL, you are using it for a SKOS thesaurus. Anyway, we don't constrain this choice unless there are some things that cannot really be done. Then you have the choices here for what I already described: the history, validation, blacklisting, and trivial inference. Here it comes to something more complicated, that is the kind of the repository that you can create. VocBench hosts, has embedded the middleware RDF4J, and RDF4J includes support for a few storage solutions, but you can also connect to an external triple store, or you might decide to access an existing repository in an existing triple store. Finally, here you have the configuration. So for example, let's say that I want to connect to GraphDB, that is a popular triple store that is fully compliant with RDF4J standard. Here you have all the configuration for this specific triple store. And for example, you might set the rule set by setting different levels of inference that can be performed by the triple store. And finally, there are some other optional settings like URI generator, rendering engine, resource metadata, the shuttle shape validations, and other options then. Let's see the peculiarity for different datasets. We have many people that are familiar with AgriVoc here, so I guess I will give you just a test drive of AgriVoc. As you can see here, there is the tree on the left. The elements are represented in 4 languages: English, Spanish, Chinese, and Italian. That are the only languages in which I have a chance to understand something. And here in the settings, you might choose various possibilities for what is represented there. Here you have a choice for the kind of exploration. The tabbed view means that every time that you click on a new concept, then a new tabs open, and you can go back and forth between the various tabs. Another view is instead the split view. Oh, sorry, I click on the wrong gear. Oh. The split view allows you, for example, to open a resource, and then from that resource, opening another one without having to move from the first one. So in this way, you can easily do comparison checks or whatever, or in general, not lose the focus on the first one. As a thesaurus, you have here a representation of schemes, of collections. There is no collection in AgroVoc, but anyway, if there were, there would be represented here. We have support for both standard collections and ordered collections. Here, the list of properties, data types, because you can coin new data types in VocBench and reuse them, and also classes, because it's a thesaurus. So, for example, in the case of AgroVoc, there is no need to have other classes. You just reuse the standard ones of AgroVoc, of SKOS, sorry. But you can always intertwine all the SKOS. You can create new classes, for example, subclasses of SKOS concept, and reuse them in the thesaurus. And VocBench allows for all of it. This is the list of preferred label. Obviously, there is some abstraction here because, for example, these labels are SKOS Excel. So you know that indeed, this is not just a value. This is a URI. And here you see from the tip when I hover with the mouse. But if I click on it, indeed, I see the resource for what it is. Indeed, the resource is Excel CS 1299, blah, 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 blah. And then it has a literal form, spare key. When you are here, you simply, since the system knows that the literal, the lexicalization model for this thesaurus is SKOS Excel, then it knows how to perform the queries for representing its content. One word about the SKOS definition. You might see this is also a particular thing, because if I click on here, I go. Also, this definition is reified. There is actually possibility in SKOS, actually 3 different possibilities for representing definitions. One is to have them simply as literals. One is to point to a resource on the web that contains the definition. And another one is to have it reified. There are 3 different ways. These are not coded in VocBench as the literal, the lexicalization models are, but indeed there is a possibility to customize the way in which you create a definition. For instance, now if I create a definition, I get more information. For example, the source where I found the thing that inspired the note that I have to write, in this case a definition, and if there are related resources to that. So this information is available when you create a form, and this form has been written with a custom form option. Let's see other aspects. I want to show you, for example, for what concerns ontologies. Let's open this ontology. And you can see that there is support for Manchester syntax. This is very useful when representing ontologies, because you don't want to write triple by triple the way that a logical axiom is written. In this case, we say that a city is something that is located in some state. Now, this is written in triples. It's written by saying that the city is a subclass of a blank node that is of type restriction, that says that on the property is situated, the value must come from the, there must be some value from the class state. But this thing can be written definitely more, instead of writing triple by triple, can be written definitely more in a more understandable way by using this dedicated syntax that is called Manchester syntax. There is obviously a dedicated editor. You can, there is syntax completion for that. You see, I've read ST, and then I can complete it with the proper elements. But it was state, so let's go back. And in any case, there is a cancel. So you can see before there was a check telling, there was that triangle telling that there was an error, because there are both syntax and semantic checks. I mean, technically speaking, the syntax is correct because it corresponds to an expression that is proper is valid in the Manchester syntax. But there is no object that corresponds to star. So in this case, what I performed is a semantic check telling that this element doesn't exist in the current. And indeed, it says the resource style is not defined. One thing about the terminological view, let's go back to the AgriVoc thesaurus. Like I said, VocBench tries to be the most usable as usable as possible, but it's also true that the more functionalities you have, the more editing you need to do, and it's a native RDF editor, and the more maybe you need to show many details and have buttons with a lot of options, etc. If you are a terminologist and you really don't want to see all these details, and maybe you even don't want to care too much about the semantics, but just care about using the proper terms for describing a thesaurus, then you have your term view. The term view is inspired by the user interface of the Yati browser. Yati is a terminological resource from the European Commission. And we got inspired by that interface that is for browsing only, but we use it actually for the editor. In this case, you have flags. Okay, again, you can change them with the language codes if you prefer. And you can see them in those cases in which the flag was not available in the system. When you move to a flag here, you are just redirected to the flag. If you select a flag that is grayed out because it doesn't exist, then it means that you can create that term. The terms, you don't need to have buttons or whatever. You just click on them, you edit them, and you can add definitions. And in this case, normally you can just click here on the definition, you start writing. But in this case, since we adopted this custom form for definition, in this case, you have to write the information in the form. I want to show you one example of the usage of metadata by the platform. In this case, it's not for the creation, it's for the exploitation of metadata. So let's go on the Gamut thesaurus and let's look for the concept. Let me take something that I remember. Chemical process, because I remember that there's some. So chemical process is here. And you can see among the other properties that there are these two close matches and this exit match with a concept from EuroVoc. I want to see, because I only see a URI, I want to inspect it. And I click on it, and I'm seeing the content of this concept. Where does it come from? It comes from the web, because VocBench is also a linked data browser. If you look here on the status, you see that the access method is Sparkle, and the remote dataset is EuroVoc on this endpoint. How does it know how to query this dataset? It knows that because on the metadata registry of VocBench, there is an entry for EuroVoc saying that it's available on this Sparkle endpoint, and that there is these URI spaces and blah, blah, blah. So he knows what he has to do in order to retrieve his content. Also here, it didn't, another possibility is that if you don't have any information, VocBench attempts to perform an HTTP dereferentiation. In this case, he has a Sparkle endpoint, so he could do also a better query to retrieve this information. But he didn't, because he sees that there are also lexicalization available in plain SKOS. So there is no need to show also the others in SKOS Excel. How does it know that? Because the metadata information reports all the lexicalization sets. This information is available thanks to the LIME vocabulary. The LIME vocabulary has been developed by me and Malia Fiorelli in the context of the Ontolex community effort. It is a module of the Ontolex-lemon vocabulary that takes care of metadata. The original name of Ontolex was Lemon, So we thought that lime was a proper name. It stands for linguistic metadata, but it's also very nice to have lime and lemons. So this is what I get. But now I turn on this Eurovoc. This was sleeping, this project. Now I open it, and then I go back to Gamut, go to the data, search again for chemical process. And then I go back here, and I see that this has been automatically resolved, and it's already shown with its proper labels. When I click here, I see the status, and the access method is local. I have accessed a local project that is called Eurovoc 2020-630. So the metadata registry coordinates all of these actions by saying, okay, there is an open project, you can access it, and it's providing all this information. Or there is not, okay, let's look, is there something on the web? If there is, okay, because I already know the information, I have this entry for Eurovoc telling that there is a Sparkle endpoint. Or if there is not, I try to go on the web and I try to retrieve information. Okay, now, Marco, how much time do we have? Because I forgot when I started.
So the official, we have another 10 minutes official presentation time, and then we have the Q&A.
Okay, perfect. I will show you another another feature that is actually it's a combination of features. So in 10 minutes I can show you various aspects of VocBench. Let's try to create a new project. I want to show you the use of shackle within VocBench and what VocBench can we do with shackle. So let's create a project. Let's call it, I don't know, demo shackle. Custom form, because I want to show you custom forms, and also FOF import. Not preload any data because we are going to create some data in it. We create a base URI for that. It's not really important. So just demo shackle custom form FOF import slash. I put the ending slash because I want to create data, and probably it's better to use ending slash with data. I can keep OWL and RDFS as models for the semantics and the lexicalization. I'm not specifying here anything because I'm creating an in-memory system just within VocBench without connecting to an external data store, because it will be something simple and easy done now just for a demo. So that's all. The project is created. The idea for project creation is convention over configuration. If you don't need to set up anything, you don't need to fill a lot of fields. You just go. Now, let's move to that project. I call it demo. Okay. So FOF import, here it is. And let's see one features, just a side effect of this demo, because the demo is about shackle, but I want to import an ontology. Now, I can do it in many ways. I can import from the web, and I can import from the web to the mirror. I can use the ontology mirror, which has a few ontologies in it. Or I can use a connector to a dataset catalog. Dataset catalog are sort of Googles of the semantic web, where actually you don't know exactly what you are looking for, so you make queries. For example, I go on Love, which is about vocabularies. It's the linked open vocabulary service that was originally developed by Mondeka. And I look for something about people, which FOF is. And I get some ontologies. And here I found also FOF. Here you see you have a faceted search and the description of the metadata and blah, blah, blah. So I'm importing FOF. And here we are. Let me add, because it didn't do automatically. This is something that we changed recently and we need to fix it. Let me add it to the list of prefixes. Namespace, we can use the prefixes service to get automatically the prefix that is best suggested for FOF. And here we are. And here is the ontology that we imported. Now, we don't need to create anything new in terms of ontology. We want to create some data, but also we want to use shackle. Shackle is, I think that I don't need to explain it, but say it shortly for those who are not familiar with it. It's a constraining language that works not at the semantic level, but works really at the syntax level. It tells you exactly which are the let's say templates for triples that you want to be respected when you create new information. I show you one shackle shape. This is a, one moment, I need to move it to the screen. This is a shackle shape for the class fourth person. Here you see the declaration. This is the name of the element. It's of type node shape and has a target class fourth person. That means that it's a different object from the class that is representing the domain objects. It's an element that describes how those domain objects that belong to the class person how they should be represented, exactly describing the shape of the triples. That's why it's called a shackle, where the SH stands for shapes. So we see that we have these various properties entries. Notice that the concept of property in shackle is not really a property, a single property. It's the general concept of a characteristic of an object. The shackle as a kind of object-oriented let's say, perspective on the data. No? So a property in general might be a characteristic that might be expressed through a property path that is long, is going across different hops in terms of triples. In this case, we have simple paths. So it's just one single property. It says that on the property given name, you can have only one, no more than one name. At least this is not something necessarily for FOF. Maybe FOF says that you can have even two names. But maybe in the database that we are building, we want people to have only one name. So we have this choice for the property given name, this choice for family name. Then for nick, we say that you can have more nicknames or you can have known. And then there is this more complex construct. It says that on the property for account, you must have at least one account. And because maybe, I don't know, all the people that you are describing belong to some organization, you want to describe the ID for this organization. Then they may have other accounts, but you want to at least specify the ID for that organization. And then it says that on that single account, because the account in FOF is a complex construct, you might have one and no more than one account name, and on each single account. So you may have even more accounts, but each single account is constituted of one single name and the service to which that name refers. For example, it can be my ID in Skype. So I could say that this is Skype in the account service page, and my ID is the one that I use for Skype. Or my code for my ID for my university when I was a student, for example, I had an ID. No? So in this case, I could say that this is the registration service for the university, and this is the ID for the university, whatever. Anyway, I'm using these shackle shapes. So I'm telling to this data set, oh, sorry, I forgot one thing. I need to do it from scratch. I will do it quickly. I needed to activate the validation shackle. Let's say that let's save the name of the project. So, okay, let's create it back. So again, this HTTP. Whatever, it's not important. Okay, so I need to add this information. Optional settings, shackle needs to be validated, enabled. There are other options, but this is all fine, and just go with that. Am I forgetting anything? I guess no. I create it. I go back here, and then I'm on, let's say it's here. I go back to here. I need to import FOF. Let me take the namespace of FOF. In this case, we will go, I mean, I'll show you before the dataset import, the dataset catalog import. In this case, I go directly for an import of, let's add the FOF prefix. And here again we are. So see now there are these options, load shackle shapes. So I will add these shackle shapes, shackle, person foof, and here it is. So what happens now if I try to create a new person? I want to create Armando Stellato, and then I will add the other informations. This is not possible. There is an error. This is just, sorry, we are missing here, there should be a writing like a shackle shape not respected, something like that. This is missing for some reason. Anyway, the important thing is here, you see the offending code of the shackle shape telling you couldn't create this instance this way, because an instance cannot exist in the triple store if it's not respecting those information. But then you say, okay, but I need first to create the instance, and then I need to add those information. How can I do? The solution is this one. You can create a custom form that allows you to prompt all the information that is required to prompt that information. How to do that? There is the custom form entry, and here you have a language for specifying custom forms. However, it's not, I mean, it's something that can be easily learned, but you know, it's like the writer, the so-called white page phobia, how to start. I'm just learning. Okay, VocBench helps you because it says, okay, there is this language that we adopt for creating custom forms, but in the end, if you have constraints telling you what should be respected, they can at least inform the basics for knowing what should be created. And indeed, that's what we are doing. I'm saying, please check the constraint that was defined on the class fourth person, the one that you have seen in the file before. Take it from the shackle graph that has been just loaded. And here it is. VocBench is already guessing what you might need. He's telling, just briefly, this language was used for creation of information when you are retrieving information for tracks, for example, in information extraction engines. And this is what we will look for. What we are doing here is that we are creating the nodes that will be shown in the graph. And so, for example, we know that there is a person that is being created. There will be an account that is being requested, a family name, a nickname, 0 or more nicknames. These are annotations that also drive the creation of the user interface. And then the given name. What is missing? It's missing the account that is not so detailed as it was before. Now, since we are running out of time, let me just copy some code that shows you how to go more into the details of that. One moment, I'm taking it. Okay, this is the part that I need to add. Basically, I want to add an account. See here, there is this account, and this account is an online account. On the property service on page lists the web uniroma2.it and then has an account name. I guess I'm not missing anything because the rest has been regularly, edited by VocBench, so it should be okay. And I think I need to give an ID person, and then call it person. This is just a label. Okay, custom form creating, and then I save it. Account name is used but not defined in root person. Account name, oh yeah, account name is defined here, but is not defined there. So account name, so this is the definition of account name. It will be literal, this is the label that will be shown to the user. Account name, the other one is created automatically. This URI, we might use an editor for creating it. So again, let me copy it to be quicker. Okay, I guess that's all. Prefix code I need to add. Take it from here. Finally. Okay, so that's the person. Let me just do these passages. These are not that important, but I can explain it later. So that's all, person, selected class, fourth person, and that's it. Okay. And finally, I need to create the binding, telling that every time that a person is being created, I can take the selection area from here. Every time a person is being created, I'm being prompted with that form. So you see now, I don't get the usual creation of an instance like it is in other cases. So in this case, I'm going to create Armando Stellato, then family name Stellato, nick, say start, Armando, then account name, it was my ID at the university. And then finally, you see, I didn't get the complaint from the system because I was able to create the instance compliant with what was specified by the custom form. And if I click here on the account, you see here I have an ID for the account, and there is this, this account, which is composed of the account name and the account service. Now, let me do, if I may, I will just copy and paste just to show you the potentiality. And let me just load directly in this case, this one. Okay, let's see it. Account. I want to show you also the account with a preview, and the account name. I want to use this as table and add the what is account service on page. Yes, and the account. Okay. Again, now let's create a collection. So account. This is telling that when this is activated, it will necessarily create the account in that way. And now you see, I actually created another custom form that is not for creating a resource directly from scratch, but for creating the value on a given property. And I told that when you create an account, you must provide two information: the account service on page and the account name. So, for example, I could create another one. Let's say in Italy, my tax code, no, whatever it is, and then I prompt it. Oh, it is a block node level. Sorry, there was a mistake in my custom form account. Yes, let me fix it in a moment. Ooh, a mouse rotate scrolling. Okay, so go back to the account editing. So on the account, yeah, he was already here. So let's use this account. Let's go back here. Sorry, I must have done some other mistake. I don't get that. Anyway, this is not a problem. I'm sorry, because I just noticed a problem with the account. Saved. Ah, this is just because of the previous value. I understand. So okay, now I can create a new one. And here you see. So this is a kind of table preview in which you have various values of which you are not interested, for example, in representing the URI, but you're interested in seeing the values of these URIs. So by a combination of custom forms for creating both the person and the representation of these elements, and the custom forms have associated a kind of preview, then you can have a very convenient view for the elements that you are creating. And you can respect the shackle shape that you decided to adopt for your own dataset. That's all. Just a few words about what is coming for the next versions. Next version is 10 and will be released in June. And it will contain just a few more updates and some features. On the big side, I mean, the big things that are coming that I can tell, we would like to support. At the moment is not on the roadmap because we were waiting for the standard to become more consolidated. But I see that there is already a wide support by many table stores, and in particular GraphDB, that is the one mostly adopted by VocBench. And there will be, for sure, I think, I opt not to be too reductive, but I think that is important. We have many other features that I didn't show, and it's important to consolidate many of them. They are all working, they are all functional, but you know, you can always do better to make them more user-friendly and simple to use, etc. One big thing that we will do, hopefully, if the project passes since next year, is a knowledge acquisition platform to be a companion of VocBench for extracting information from unstructured content, be text or any form of semi-structured information, and to import it into VocBench. Another thing that will be out soon, I mean, it's ready, it's working, it's here, for example, I can show it. It's a companion to VocBench that is, sorry, it needs to be refreshed because I was out for a while. It's a companion to VocBench for publication. As you can see, this platform is completely, I mean, there are no buttons, nothing, because it's just for browsing, but it's definitely I mean, appealing for the end user. And there are also interesting things such as the inspection of alignments that can be done through tables and graphs in a very convenient way. For example, in this graph, you are seeing each element is not a resource, a single resource. It's a whole data set. And these edges are representing the alignments that exist between a data set and the other ones. So with this, this platform it's based on the same underlying technology of VocBench, this semantic Turkey, and it will be available soon. And that's all. So thank you for that. I hope that I didn't go too further with the time limit, and I'm available for any question if you have any.
Okay, very good, Armando. Thank you very much. Very impressive. It's amazing how you remember all the steps.
Well, it's a bit of improvisation because obviously, I mean, we designed that, so I know how to use that. I'm sorry for losing some time in that part. I would like to I mean, probably I was running out of time, so in the end I did some mistakes and I didn't have
Well,
much time.
there will be other presentations. You know, we don't have to do everything in one.
Yeah. Also, what is important is to show where you can go to. I mean, the steps in the middle, somehow you just need to learn and to see how they work. This was just mentioned, was meant to be showing, what is achievable with that.
Okay, so we are, this is the end of the official presentation. We're now having a Q&A, and then we open it up to everybody after the Q&A. But let's have a quick look at the questions. Let's start with Jay Gray. He is developing his vocabulary with OWL2 semantics, and he uses Protégé currently, and he was wondering if it's possible to import OWL2 Protégé models in VocBench. And maybe Jay, feel free to add to your question as well.
Yeah, that hits it. Armando, we use Protégé, and our models are all in OWL tools. So my question was, to what degree can we import and export those with VocBench?
Well, there is no limit to that. I mean, I regularly do because no, regular is a big word, but sometimes, for instance, I might have something that I don't know, somebody hands me a project directly the folder now in Protégé, or for any other reason I'm opening something in Protégé, and then obviously I end up editing it in VocBench, and I just export it, and that's all. The only limitation that there is that Protégé uses the OWL API. So OWL API have their strong and their weak points. So the weak point is that they don't handle everything about RDF. I don't know about what is about Sparkle, and I don't know what is the scalability of OWL API, but one advantage that they have is that with respect to RDF4J is that they support natively the OWL syntax. RDF4J doesn't support. VocBench supports all the, simply by reflection, supports all of the standard serialization formats that are supported by RDF4J. So this means practically all of the existing serialization formats for RDF, both for triples and for quadruples. Unfortunately, the only syntax that is not supported, because it's not based on RDF, is based on the OWL syntax, which is completely an abstract syntax that is disconnected, let's say, from RDF. It's exactly the OWL2 syntax, the one that is often referred as OWL/XML. But the only thing that you need to do is that when you export your ontology, you export in any other format, and then you import it in VocBench.
And there is a question also by Jay about the integration of his own reasoning subsystem. I think you mentioned Prolog that is currently being used in VocBench. I presume there is there an opportunity to have a third-party reasoner?
At the moment, we support, because we were considering adding other reasoners, but in the end, at least for the moment, we abandoned the project because, you know, the thing is this: either you have a reasoner that is built in your triple store, and this is a very efficient solution, no? Because you might work even with billions of triples, and your reasoner, that obviously then it's a matter of performance. You must choose some reasoner that scales up to those quantities of triples. But once you have it, it must be in your triple store. Otherwise, you would be just converting all your ontology into something that the reasoner can get and then will reason on that. I remember that in Protégé, for instance, there were connections to Hermit and to some other reasoners, in which some cases you were just transferring the ontology to that other reasoner. And obviously, this is not something that scales up to very large amounts of data. So for the moment, the reasoning support that is available in VocBench is the one that is provided natively by the triple store. If you look into the documentation of RDF4J for what concerns the triple store that are embedded with that platform, or the documentation of GraphDB, you will see that there are plenty of levels of reasoning that are supported, and you might work well with them.
So the question was driven by this idea, Armando, that we actually use Reasoner in the protege environment, not so much against the triple store. We use Hermit, as a matter of fact. So it's a quality control process. And that was the basis of that question. Not so much run against reasoning, running against the triple store, because that's very expensive. What we're trying to do is to control the content that goes into the triple store, not query the triple store in a reasoning process, if that makes sense.
I may have got something wrong, but let me clarify one thing. When I say triple store, you don't have to think of the triple store like the ending part where you are deploying your data for publication. I'm saying whatever form it is, if it is something separated from the application, or if it's something embedded in the application, in VocBench there are both solutions, but I'm talking about the solution that is used for storage of the information. So in a sense, even Protege has a triple store. It's just that it's that is provided by the OWL API. So the thing is, actually, it's not inefficient. It's the contrary. Something that is within the triple store is efficient because it's directly, connected to the very place in which you are storing the data. So the thing is that in Protege, when you are using connectors to external triple store, to external reasoners, you are transferring your ontology. It works if you have just an ontology. It doesn't scale up if you have a lot of data. I know that, I don't remember if it's Hermit or another one, there is a recent reasoner that is quite performant and also quite expressive. I mean, covering quite a lot of the expressivity of OWL, and is based on the OWL API. That's why they use that reasoner, because it's using the same API that they're using for storage. Okay,
correct. So that's why we use the Hermit reasoner for exactly what you're describing.
It's Hermit, yeah. So the thing is, in our environment, we use another environment that is not the OWL API. We use the F4J. The F4J, you can decouple it. It has some storage solution within, as OWL API have, but there is also the possibility to connect to external stores. And in this case, for example, if you want a good reasoner, probably GraphDB is the solution for you. I don't know if it's as powerful as Hermit. I guess it's no, the answer, because obviously they always think in terms of, a large scalability. So I don't think that all the possibilities that are offered by Hermit are offered by GraphDB, but I might be wrong. I suggest that, I may invite you to check on the documentation of GraphDB to check the level of implementation, I would say the coverage of the expressibility of the OWL language and what can be inferred on the basis of it. That is covered by GraphDB.
Jay edits here that AgroVoc in VocBench is beautiful. And he says,
thank you.
How many triples can you realistically manage with VocBench?
Well, the answer, we have done a lot of work recently. Sorry, there was no time for showing everything. And also the best, let's say, the best benchmark that I have is something that I cannot disclose because it's for a consultancy. And it's a dataset. It's not an ontology. It's not a thesaurus. It's a dataset. It contains millions of triples coming from projects that are funded by a foundation. And there are information about people, information about projects, information about the evolution of the projects, all the various steps, etc., etc. There are tens of billions of triples. And VocBench works like a charm, I must say. I mean, I don't want to be like someone working in marketing. We already have Johannes for that. Yeah. But I'm happy to say that this is the result. The point is this: when you are within VocBench, I know the screen is not shared. Anyway, to make it short, all of the graphical parts that you have already seen, trees, lists, etc., react to the number of triples that they are showing. or better, to the number of elements, because a problem might be before it's a problem for the server. It might be a problem for your browser. When you're showing like thousands of elements, imagine a tree where just the root elements are 5,000. This might be a problem. Actually, we have been very surprised to see that with modern machine, with the Angular framework, same with the latest versions of the Angular framework, which are much lighter and faster, it is possible really to load even thousands of elements in the user interface without clogging it. But when you go in the terms of tens of thousands of elements, then things get a little more complicated. So what we have implemented is that every single element that you're showing, when it's going to show too many elements, then it will activate, it will suggest you to activate another view. For example, for instances, you may move from the list of instances that can be scrolled, and there is paging for that, obviously. But when it's really too much, you may move to search-based showing. That is, as a basis, it doesn't show any instance, but when you put a string, then you can get the list of instances that is matched against that string. And this thing can be done both for the list of instances, but also for the tree. For example, take as an example WordNet. WordNet is a very big lexical database. And it's true that, for example, for the synth sets, which are represented as lexical concepts in Ontolex, there is a tree, like there is for any concept tree in SKOS, no? But the problem is that WordNet, for what concerns the verbs, is totally flat. I mean, there are some hypernymy relations between verbs, but for the most, it's a very long list of verbs. So what you can do is that when you load WordNet, it sees that it's showing too many elements, and then it asks you to move to index view, for example, by seeing only the initials of every word and listing only the words that start with that character, or moving again to search-based view. So this is working with VocBench in all the parts of the UI, and we are always working to improve this aspect. We don't want the platform to be stuck by too much information. But for what concerns the server, I really can send you to check the benchmarks of GraphDB, and you will be pleased to see that we are talking about even much more than tens of millions of triples.
Okay, we'll get two more in the Q&A question, and then we're opening up to everybody. We turn off the recording and we go offline. There was one with regards to consulting. So is there a commercialization strategy in place for VocBench?
Yeah,
and
sure.
A question by Eugene.
Sure. Well, there is, I mean, VocBench basically is a platform that comes totally for free. I mean, we're already getting funds for developing it from the European Union, and we don't want to, I mean, put any constraint on the use of VocBench. So VocBench as a basis is freely available. It's open source. And not only, it can also be repurposed for commercial use. The only thing that you need to do for the license, the BSD3 license, is that you need to properly refer to the original project that has been altered in case. But obviously, I mean, there may be organizations, companies that do not want to do everything on their own, and they want to be helped in that. So we provide different kind of consultancy. Obviously, we provide consultancy even for what concerns, in general, support in developing semantic resources, in publishing, how to publish semantic resources, any kind of consultancy in this area. For what concerns VocBench, we provide hosting of the platform. At the moment, we are doing this through the university, not through the spin-off. And for example, we have two contracts with, a contract and a letter of agreement, let's say, with the Food and Agriculture Organization. We are hosting AgroVoc for them. And also we are hosting several statistical resources for the statistical department of FAU. And we have also provided consultancy to many other clients for helping them to create their own instance. So they have their premises, they have their IT department, but at the same time, maybe they need to be bootstrapped. So what we do is we help them to set up the environment, and they are free to go with their own legs. So, I mean, it's open to whatever is the need of the specific customer and can be tailored to this need of the specific customers.
Yeah. If I may just very quickly clarify this a bit. So I think the original question was also about working with development communities. So for example, if let's say, whoever has time on their hands or interested in VocBench development and spotting sort of specific improvement opportunities, how does that work with, I guess, the sort of commercial branches? There's still some sort of roadmap that you're planning on sharing with others, so people can sort of pick the features off the list, so to speak. I can think of a couple.
Thank you. Well, I'm not sure I got one part. You mean for supporting in developing, like, for example, extensions for VocBench or customization or repurposing, or?
Yeah, so even a simple improvement,
Yeah,
for
no,
example, right? So for other projects, typically you clone a project, you go through one way of review or another, the pull requests and all the rest of it.
Sure.
And these changes get accepted, etc. So if you have something like that, then are you planning to keep that, even though you're sort of spinning off the commercial part of it?
No. I mean, again, we do that in a very flexible way. You have seen in VocBench before. I highlighted it when I heard mentioning the Onto portal, that there is an Onto portal exporter now, and this has been asked by the LifeWatch consortium that is using customized edition of the Onto portal that is called Echo Portal, and they asked us to develop one extension that would support export to the Echo Portal. Then the consortium decided also to contribute this to community, and this is now part of VocBench. But there are also other per partner developments that have been done on VocBench and that have been developed as extensions, so that the partner doesn't need to, to create a fork for that, but they will just get at the most they need an update of the extensions every time that VocBench goes out, and maybe not always, because maybe that part is untouched. Another thing is the exporter for the Z-test and the importer for the Z-test. That one was requested by the Gelbseiten, that is the yellow page service of Germany. And we developed that for them, and they decided to contribute this to the community. These are two parts which are currently embedded with VocBench, because the partner decided to make them part of the platform. But there are others which are being developed specifically for the needs of some partner. They didn't need to be they didn't want to get it disclosed to the community, also because in some cases it resolves very specific needs which wouldn't make any sense for the general platform. But that's how we proceed. In general, we see case by case. There is we have a plan for what is the development, the roadmap, and how much will be the effort and the budget, and that's all.
And we can discuss that in the after session a little bit more. I just want to latch on to Nawal's question. So you mentioned already Onto portal. Nawal wants to know more about Onto portal's connection between VocBench and specifically how to work with the ontology metadata, possibly also addressing versioning.
Oh, that's a lot. I should make complete another demo. But
maybe a short answer to Noel, and then we open it up to everybody.
I'm joking. Obviously, it will be short. I don't know if I'm sharing the screen already.
Yes, you do.
Do you see VocBench?
Yes.
Okay. So just in short, when there is something that you developed, here you have this global data management. One option is to deploy to a triple store, but in this case, it's in a broad sense. It can be a deployer for Onto portal. And in this case, you might choose the specific implementation, and then there is a configuration, and then you can specify all the metadata that is requested by Onto portal. And that's all. And this way, you don't need to export your ontology, then connect to the OntoPortal site, upload your ontology by filling the forms there. Also, configuration here can be stored. You can see that there are options for storing and retrieving, so that if you are maintaining an ontology and you need to export it to OntoPortal regularly, then you can do it much more easily with VocBench. This is what is available now. Maybe there will be future collaborations again with LifeWatch. I'm also in touch with the developer of AgroPortal, and or in general with the OntoPortal community that is, you know, the supporters of different OntoPortal implementations. The idea is that we could also do the reverse. For example, accessing to OntoPortal as a dataset catalog in order to get information from that and download the ontologies and the datasets that are hosted there. And then more can come. This is just, I mean, what we already have, what probably will be done in the near future. And if you have an idea also, I mean, we are happy to receive feedback.
Okay, I think this is a good time to, you know, close the official presentation and Q&A. Thank you very much again, Armando, for your time and the presentation.
Thank you.
It's amazing to see how the semantic web technology has come along in the last 20 years and how powerful it is, but also how complex it still is in terms of the user interface. And I think it needs a certain level of expert knowledge to make it shine and make it work for your application. But again, it's good to get this update. So I'm now going off the record